So question one was testing your ability on whether or not you can read a graph. The idea is that f of x or g of x or whatever the letter is simply asking you for the y value for the function output. So for letters A, B, C, D, and E, I'm just asking you if you saw something like this, it's asking what is the output, aka the y value, when the input, aka the x value, is -5. So there really is no calculations. You couldn't do this unless you could read. So for letter A, what is g of -5? I look at x equals -5 right here, and then I look at the graph. So clearly I can read that g of -5 is 3. So you just go through the same logic for every single one of these letters. So let's take a look at letter B, g of -3. So I look at x equals -3, and then I go straight up to the graph. What is that y value? That's going to be 2. G of -1. Here's -1. Go to the graph. What's the y value? It's -2. G of 1. Go to x equals 1 right here. Go to the graph. That's going to be a 1. And then g of 3 is right here, which gives us a 0. Now, in terms of finding the domain, you have to recall that the domain are the x values, so you literally just trace the graph from left to right and see what x values you cover. So the graph starts here, and if I trace from left to right, it does break apart here, but we can just continue. So hopefully we can see that this graph going from left to right starts here and ends here. So that's there's our domain. So it starts at -5 and then goes all the way to 3. Number 2, finding the inverse function. Finding inverses algebraically is just solving for x. So the first thing I would do is change it to y equals, and then all it is really algebra. Not a lot of heavy concepts here. So get x by itself, we're going to subtract 2 from both sides. And then to get rid of the square root, you're going to have to square both sides. Recall when you square a binomial, please don't make the mistake. There is a middle term. You should have a trinomial here. So this is y minus 2 times y minus 2. So if you did not do the distribution properly, you would get the wrong answer. So y minus 2 squared is going to be y squared minus 4y plus 4 equals 4 plus x, and then subtracting 4 from both sides, you get y squared minus 4y equals x. And then the last step, since it technically wanted us to find x inverse, is to swap out the variables. So this is x squared minus 4y 4x equals y, and then just write it in function notation. So your answer should have been f inverse of x equals x squared minus 4x. Number 3, find the average rate of change. So we just had to remember that the average rate of change is nothing more than the slope formula. So it's the y value of the latter x input minus the y value of the first input all over the differences in the inputs. So notice in order to do this problem, we need output values. I only give you input values, so you just have to plug in those input values to find those output values. Let's find f of -1. So you just plug in a -1 for the x's. So that's -1 plus -1 to the 4th power, which is -1 plus 1, which is 0. Let's find f of 3, which is 3 plus 3 to the 4th power. That's 3 plus 81. That's 84. So then let's just do y2 minus y1 over x2 minus x1. So the average rate of change is f of 3 minus f of -1. You always do the function output of the bigger x minus the smaller x all over 3 minus 1. So that's going to be 84 minus 0 over 3 minus a -1, excuse me, over 3 minus a -1. So that's going to give me 84 over 4, which is a 21. So the average rate of change for number 3 should be 21. Number 4 is another average rate of change problem. The only difference is my input value has a variable in it, but it's the same concept. Average rate of change, just do the slope formula. I need the outputs. So what is f of 1? That's going to be 10 minus 1 squared, which is 9. What's f of 1 plus h? It's going to be 10 minus 1 plus h quantity squared. And again, when it comes to squaring a binomial, you have to write it out twice and distribute. So you're going to have a trinomial. So that's going to be 10 minus 1 plus 2h plus h squared, which is 9 minus 2h minus h squared. So then average rate of change is just y2 minus y1 over x2 minus x1. So average rate of change is f of 1 plus h minus f of 1 over 1 plus h minus 1. And then you just plug it in. 9 minus 2h minus h squared minus 9 over 1 plus h minus 1. So hopefully a lot of things cancel out. The 9s are gone. The 1s are gone. So we end up with negative 2h minus h squared over h. Hopefully we can see that I can cancel out 1h from all terms. So that gives us negative 2 minus h. Number 5, more average rate of change. In this case, I didn't give you a function. I gave you a picture, and it should be actually be even easier if I give you a picture, because all you can do is just count rise over run. That's what average rate of change is, that slope. So just by pure looking, I'm not going to even do any math. Between this point and this point, you rise 1, 2, 3, 4, 5, and you run 1, 2, 3, 4, 5, 6. So average rate of change is rise over run. So that's all you really need to do. Number 6, finding the inverse function. Again, finding inverses algebraically is just algebra, solve for the other variable. First thing I would do is change the f of x into a y, easier to work with the algebra. So let's solve for x. Subtract 9 from both sides. And then divide out that negative 7. It's sort of weird to see a negative in the denominator, so you could have left it like this, or if you wanted to apply the negative to the numerator, that would have been fine as well. Of course, the last thing you want to do is swap up the variables. So instead of x equals, we have y equals 9 minus x over 7. And then go ahead and write it in function notation. So the f inverse of x is 9 minus x over 7. Again, if you did not apply the negative and you left it as x minus 9 over negative 7, that would have been fine as well. Number 7, average rate of change. Hopefully you guys were told of the correction in the picture. The story says it's a 100-meter race, but the graph scaled it by 4. So this should have been 100. This should have been 50, right? But average rate of change, it's just, the final point minus the initial point. So the idea is, although these 3 pictures are all different, these 3 curves are all different, they all start at the same spot. They all end at the same spot, so conceptually they should have the same average rate of change. It's just rise over run. So hopefully you guys can see that the rise is 100 and the run is 80. So that's basically what this problem was. Average rate of change was 100 meters over 80 seconds, which was what, 5 fourths meters per second. Okay. So for every single one of these questions, it should have been 5 fourths, 5 fourths, 5 fourths. Okay. Because they have the same start and final point. Number 8 was more just graph reading, but the idea is that if a regular function, the idea is that it takes in x's and spits out y values, then inverse function takes a y value and spits out x's. So for letter A, for example, if you saw this notation, this is asking you what x value has a y value of -1, right? So because we're using an inverse function, this guy here is actually an x value, so the full answer is looking for a y value. Excuse me, let me rephrase that. Since this is an inverse function, whatever's in here is actually a y value, and the whole answer is looking for an x value. So with a graph, notice this graph is for the original f function. So I can look at the graph and see where is y equals -1. So well, this line here is y equals -1. Well, what part of the function has a y value of -1? And hopefully we can see it here. What is his corresponding x value? Oh, it's 2. So the answer is 2. Okay. For letter B, it's asking you what is the x value for the y value of -7. So it sort of went off the page, but you can sort of guess -7 is right there. So here's a y value of -7. Where on the graph has a y value of -7? Right here. What is this corresponding x value? -4. So this should have been -4. And then this letter C is just a function composition. So you got to do two things at once. So the first thing you want to do is find the inside stuff. So where on the graph does the function have a y value of -3, which is right here. So what is this corresponding x value? -2. So this guy here becomes f inverse of -2. So I have to ask myself where on the graph has a y value of -2, which is right here, and I don't have to go anywhere. So what is his x value? His x value is 0. So the full answer should have been 0. Number 9, which graph is not one-to-one? This is an application of the horizontal line test. The horizontal line test states a function is one-to-one if any horizontal line only cuts the graph once. So for example, letter C is one-to-one because no matter what horizontal line I draw, each of those horizontal line only cuts through once. So applying the horizontal line test, hopefully we can see that letter D is not one-to-one because for example, this horizontal line crosses 3 times. So the answer should have been D, graph D. Number 10, idea is function composition. So it's just substituting one function to the other. So for this particular question, notice how the g of x is inside the f. So what it says is whatever the g function is, you're going to plug it into the f function wherever you see an x. So for this question, f of g of x is simply 7. Instead of x, I'm going to substitute the g function. And then you just distribute and simplify. 70x minus 28. Not much more you need to do there. Number 11 is basically the same thing, except I asked you to find the domain. So the idea is the domain of a composition is the domain of your inside function intersect the domain of your answer function. So although it doesn't ask us to find it, we're going to have to actually find the composition before I find the domain. So let's do Goff. So g of f of x says wherever I take the f function and just plug it into the g function. So that's the square root of x squared minus 20. Okay. So let's find the domain. So I need to do the domain of the inside function. And the inside function is what we substituted, which is x squared. Now, x squared doesn't have any radicals. It doesn't have any division. So the domain here is just everything, all real numbers. That's easy for us. The answer is a little bit interesting, so we actually have to do some math there. So the domain of the answer is the square root of x squared minus 20. So in this particular example, we do have a radical. So we need to safeguard against taking a square root of a negative number. So I want that radicand, the stuff inside of the radical, x squared minus 20, to be greater than or equal to 0. So this is a non-linear inequality, so we need to pretend that it does equal 0, and then solve for x. So when we take the square root, we get plus or minus, so you have to remember that. And I'll go ahead and simplify that radical. To solve a nonlinear inequality, you have to do a sign diagram. So here's negative 2 rad 5, here's 2 rad 5. They're going to be closed because of the original inequality. By now, if you still don't know what a sign diagram is or how to do it, you really need to start asking me or looking at the old lessons. But from this point on, I'm going to assume we know how to fill out a sign diagram. So if you guess and check numbers and fill out the sign diagram, you're going to see it's going to be a plus, minus, plus. And for the original inequality, we want greater than or equal to 0, which are the positive regions. So your answers, your intervals is the left region and the right region. So the domain is going to be negative infinity, comma, negative 2 rad 5, union, positive 2 rad 5, comma, infinity. Number 12 is basically reading. Can we read a table of values to evaluate function inverses? The idea is that a regular function takes in x and spits out y's. So inverse function does the exact opposite, takes in y values and it wants or spits out x values. So if you saw something like f inverse of 5, this is asking you what is the x value associated with the y value of 5. Because again, if I'm using the inverse function, what's inside here is actually a y value. So looking at letter A, we do have f inverse of 5 inside of the argument here. So just looking at the table, what x value is associated with the y value of 5? Well, reading the table here are your y values. Hopefully we can see that a y value of 5 is related to an x value of 4. So that's what the yellow equals. So this is equal to f inverse of 4. And then we just repeat the process. This is asking what x value is associated with the y value of 4. Hopefully we can see in the graph, here's a y value of 4, so its x value is 1. This is 1 here. For letter B, we actually didn't need the table. The idea is that a function composed with its inverse, when you put a function and its inverse together, they sort of like cancels out. So the whole answer is 2. I mean, yeah, you could have just done this blindly. But if you wanted to use the table here, let's take a look at it. So the orange here is asking what x value is associated with the y value of 2. So here we can see that this y value of 2 is associated with an x value of 3. So this is f of 3. And then if you read f of 3, it's asking what's the y value when x equals 3. So basically you go backwards to 2. So using the table or using the idea of inverses, letter B should have been 2. Number 13 is just reading a graph. Where are the intervals of increase? And to answer this question, you sort of have to look at the graph left to right. Actually, left to right. And just look at the parts where the graph is going up. So hopefully it doesn't take a lot of thinking. We can see that the graph is going up in this chunk, in this chunk. Now, intervals of increase and decrease are always the x values. So the answer should have been these x values and these x values. So hopefully it's very easy to see. I mean, the answer is just you read it. There's no math involved, really. The answer is from -7, comma to -3, union 6 to 10. And remember, intervals of increase and decrease, they will always use open parentheses, never close brackets. Number 14 was more just reading the graph. So 14a, find the coordinates of the vertex. So the vertex, we just read it up here. So you just read the coordinates, 3, 5. And for letter B, find the maximum minimum value. If I use the word value, I want the y value. So the answer for letter B was simply 5. That should have been a quick and easy reading a graph question. Number 15, finding the inverse. So the idea of finding the inverse is basically to solve for x, solve for the other variable. So the first thing I would do is change the f of x into a y, and then just use algebra to solve for x. Subtract 5 from both sides, and then to get rid of the 7th power, you take the 7th root. That's it. Now I did ask you to swap the variables, so I'm going to swap the variables and the equation at the same time. So we get y equals the 7th root of x minus 5. All the x's become y's, all the y's become x's, and then just change it to to function notation. So the f inverse of x is the 7th root of x minus 5. Number 16, finding the domains of functions. The idea is you're checking against two things. Square rooting of a negative number, we don't want that to happen, or dividing by 0, we don't want that to happen. So in this case, hopefully we can see there are no radicals, but we do have a denominator. So what is it that we want to safeguard against? So the idea is, the sentence here is that the denominator, x squared minus 4, cannot equal 0. That's exactly what we want. So mathematically, write it out and solve it. So add 4 to both sides and take the square root. And it's plus or minus because we're solving. So there you go. That's the domain. X cannot be positive 2 or negative 2. But in my class, I want interval notation. Visually, if you can't see that if you imagine the whole number line shaded, but at negative 2 and positive 2, they are left open. So everything else is shaded except for positive 2 and negative 2. So the domain is negative infinity to negative 2, union, the middle part, negative 2, comma 2, union, the right part, 2, comma, infinity. Number 17 was a function transformation question, and I hate to say it, but you just have to know it. This chart on the right here, you just have to know how affecting a function changes its graph. For example, adding to the whole function moves it up, subtracting from the whole function moves it down, etc., etc., etc. So you just had to read this guy here and know the transformation's present. So it wasn't a lot of complicated solving, more of reading. So if you read it correctly, this is a vertical scale by 4, this is a left 5, and this is a down 3. How did I know it? It's because I know this chart here. So which letter has those? Let's see. Left 5 stretched by a factor of 4, and then down 3. So the answer should have been E. Right. Number 18, finding the domain of a function. When you're finding the domain of a function, you're safeguarding against two things: taking an even root of a negative number, which we don't want, or dividing by 0, which we don't want. So hopefully in this example, I don't have any division going on, but I do have a radical. So you basically write down what you want. I want to make sure that the stuff inside the radical is not negative, and in math, to be not negative is to be greater than or equal to 0. Then you just solve that inequality. Add 7 to both sides, divide out by 8. That's pretty standard linear inequalities. I did want the answers in interval notation, so visually, if you can't see that, what that means is at 7/8, it's going to be closed because of the or equals to part, and I want numbers bigger than him, so you shade to the right. So there's your domain. My domain, you start at 7/8 and you go all the way to infinity. Number 19 is a function transformation question. And when it comes to function transformation, there really is no big secret. You need to know the function transformations. You need to know that adding to a function moves it up, you subtract to a function moves it down, adding directly to the x moves it to the left, so on and so forth. So in this case here, if you were to read the function, I mean, there really is no math solving. You just have to be able to, you just have to know it. That this says write 4 and down 2. So when it comes to sketching, just find points that are easily readable and then do the shift. So I can easily read this point, I can easily read that point, I can easily read that point. So I'm going to shift accordingly. So 0, 0, move right 4, down 2, there's my new point. 1, 1, right 4, down 2, there's my new point. 4, 2, right 4, 1, 2, 3, 4, I'm off the page, but okay, down 2, there I am, and then just copy the shape. So that should have been the graph of number 19. Number 20, evaluating piecewise function. The idea is you have to know that if I give you function notation, whatever is inside the input here, that's basically saying substitute whatever is in there in for x. Now for a piecewise function, you have to look at your domain restrictions because not every single x value fits in the in every single function. So let's do letter A. Hopefully we can see that letter A is asking to substitute in at x equals -4. So you look at the domain restrictions and ask yourself, where would x equals -4 fit? Hopefully we can see that it fits in the first domain restriction. -4 is less than -3. So that means you're going to use the top function to plug in. So for letter A, plugging into the top function, -4 squared plus 4 times -4, you do some arithmetic, and that's going to give you 0. So the answer to letter A was 0. Letter B, where does -7/2 fit? Well, -7/2 is approximately, well, it's not approximately, it's equal exactly -3.5, which again fits in the first domain restriction. So you're going to plug into the first equation. So that's -7/2 squared plus 4 times -7/2. So that gives me positive 49/4 minus 14, which is 49/4 minus, multiply 14 by 4. What's that? That's 456/4, which is -7/4. So the answer to letter B should have been -7/4. Letter C, plugging in a -3. Where does -3 fit into the domain restrictions? Once more, it fits into the top function. So let's plug it in. So that equals -3 squared plus 4 times -3, which is a positive 9 minus 12, which is a -3. Letter D, evaluate f of 0. 0 fits into the middle domain restriction, so plug it into the middle function. So that is a simple 0. And then evaluate f of 35. 35 fits into the bottom restriction, so you plug 35 into the bottom function. It's a constant function. There's no x's to plug into it, so it stays as -9. Number 21, the idea of finding an inverse is algebraically just solve for the other variable, solve for x. The first thing I would do, though, is change the f of x into a y, and then go ahead and solve for x. This is a rational function, so I'll go ahead and clear the fraction by multiplying both sides by 3 minus 4x, just multiply by the denominator to get rid of it. And I'm going to go ahead and 3 minus 4x. Distribute the y at the same time. So distributing this y here gives me 3y minus 4xy equals, and then on the right hand side the denominators are gone, equals 2 plus 7x. So algebra 101, solve for x. Move all the x's on one side, move all the non-x's on the other. No rhyme or reason, I'm just wanting to keep x positive. I'll go ahead and add 4xy to both sides to move all the x's to the right, and since this 2 doesn't have an x, I'm going to subtract 2 from both sides. If you went the other way, your answer should be the same. You'll just have an extra factor of negative. We'll differ by a factor of negative. So that gives us a 3y minus 2 equals a 7x plus 4xy. Since I want to solve for x, I need to isolate the x. We need to extract the x from the right hand side via factoring. So factor out the x, giving us 7 plus 4y. And then get rid of this junk here by dividing it out. So 3y minus 2 over 7 plus 4y equals x. The last step is, of course, swap the variables. Wherever I see an x, change it to a y. Wherever I see a y, change it to an x. So your inverse equation should be y equals 3x minus 2 over 4x plus 7. Since it did ask us to find the inverse function of f, I'm going to write it in function notation, changing that y into f inverse. So this should have been the answer. Again, if your answer looked different but was mathematically correct, I gave you full credit. Number 2 was a function transformation question, and unfortunately, there is no way around it. You have to know these function transformations. You have to know that adding to a function moves the graph up, subtracting from a function moves the graph down, adding directly to x moves the graph left, so on and so forth. So if I read what I'm asked to sketch, y equals negative f of x plus 2 minus 1, you just have to know all the transformations reflect over the x-axis. This is a left 2, and this is a down 1. When it comes to function transformations, it follows orders of operations. So you do the multiplying first before you do the adding and subtracting. So you're going to do the reflection first before you do the translation. So fortunately, since this is an absolute value function, all these points, when you reflect it over the x-axis, it's just flip it upside down. So let's take a look at a couple of points that we can easily read. Let's say these 5 points here. And let's go ahead and do that. Let's take let's go from left to right. If I flip this guy upside down, he goes here, and then I'm going to go left 2, and then down 1. So this should be his final destination. If I take a look at this point here, if I flip him upside down over the x-axis, he's right here, and then I go left 2 and down 1. There's his final destination. If I take a look at this point here, flip him upside down, well, he's at the origin. He stays put. So you go left 2 and down 1. Let's take a look at this point right here. Flip him upside down. He'll be right here. Left 2, down 1. And I think you guys get the pattern. But that should have been your final graph. 23 was a function transformation question, and hate to say it, but there's no way around it. You need to know the function transformations. You need to know that adding to a function shifts it up, subtracting from a function shifts it down, adding directly to the x moves it to the left, so on and so forth. So this one hopefully should have been very simple. You only had one transformations. This said down 2, so you literally take all these easy to read points and move it down 2. That's all you have to do. So this point goes down 2, 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 and then all you got to do is draw the shape, draw the picture. So connect the dots. That should have been your graph. Number 24 was a function transformation question, and I hate to say it, there's no way around it. You need to know your function transformations. You need to know that adding to a function moves it up, subtracting from a function moves it down, adding directly to the x moves it to the left, so on and so forth. So in this question here, the original graph is the dotted graph. I have to find where the new graph would be if we did these transformations. So reading it, we have a vertical scale by 2 and then left 6. And I hope this was a very obvious question. There is only basically one graph that took the dotted graph here, that took this graph to the left 6 and vertically scaled it. The answer should have been graph 2, which was letter A. Number 25 was evaluating an inverse function. So I gave you the actual equation. So technically you could have found the inverse function and then plugged in 33. But the idea is that a regular function takes in x values and spits out y values. So an inverse function does the exact opposite. It takes in y values and spits out x values. This idea is that the relationship between a function and its inverse, these y values are the same. So if I gave you an equation, f of x equals 3 minus 6x, this guy here is the y value. So I'm telling you, find the x. So f inverse of 33 is asking you, hey, what's the x value when the y value is 33? So you can change the highlighted into 33. That gave you a simple linear equation to solve. Subtract 3 from both sides. Divide out the negative 6. The answer should have been negative 5. Or rather, let's write it in function notation. So x equals negative 5. So the answer should have been f inverse of 33 equals negative 5. That should be your answer. 26 is asking to find the average rate of change. So the idea is that the average rate of change is nothing more than slope. So average rate of change is usually between two input values, two x values. So what you need to do is find the y value of one input minus the y value of the other input divided by subtracting those inputs together. So the question gave you your inputs, 1989 and 1999, so you have to find them on your chart, 1989, 1999, and hopefully, just there are your 2 points, 1989, comma 545, and then 1999, comma 695. So then again, you just use the slope formula. So average rate of change is slope. So it's, x1, y1, x2, y2, 695 minus 545 over 1999 minus 1989. So just break out well, actually, we don't need a calculator. This is pretty simple enough. That's 150 over 10 years, which is 15 CDs per year. Right. Number 27 is a function composition. Basically, that's like nested functions, work inside out, just plugging stuff in. So letter A, f of g of 1. So g of 1 here is just asking you, hey, whatever you see an x in the g function, change it to a 1. So let's do that first. G of 1 is, I'm going to use the g function here, is 5 minus 1 squared, which gives me a 4. Therefore, f of g of 1 is just f of 4, right? And then that just tells you to take the f function, wherever you see an x, plug in a 4. That's 2 times 4 minus 6, which is 8 minus 6 is 2. So the answer should have been 2. And for letter B, just work backwards. I'm doing g of f of 1. So let's find f of 1 first. So that's 2 times 1 minus 6, which is a negative 4. So g of f of 1 should be g of negative 4, which means take the g function, plug in a negative 4. That's 5 minus a negative 4 squared, 5 minus 16, which is a negative 11. Okay. Number 28 was basically asking if you could read a graph. So you have to remember that gof of 3 is the same thing as g of f of 3. And remember that f of 3 is asking you what is the y value when x equals 3. Now, since it is of the f function, you have to look at the f graph. So looking at the f graph, where is x equals 3? Right here. What is the y value? Oh, clearly it's 0. So this is the same thing as g of 0. And then this is asking you right here, what is the y value on the g graph when x equals 0? Where is x equals 0? Right here. And then you go straight to the g graph, which is up here. So the answer, what is the y value, is 3. Number 29 was a function transformation question, and unfortunately, when it comes to function transformations, it's you either know it or you don't know it. You have to know these transformations. You have to know that when you add to a function, it moves it up, subtract from a function, it moves it down, adding directly to the x moves it to the left, so on and so forth. So in this case, I wanted you to read the transformations and then build the function. So I wanted you to take f of x equals radical x and shift it 3 to the left, scale it vertically by 5, and then reflect in the x-axis. So hopefully you can see that moving to the left, I have to add directly to the x. Scaling vertically, I need to multiply the whole function. And then reflecting the x-axis, I need to make it negative. So the answer should have been negative, scaling by 5, negative 5 radical x plus 3. So there is your function. So again, if you need to see where the pieces are, this flips it over the x-axis. This is your vertical scale. This is your 3 to the left. Number 30 is a function transformation question. And when it comes to function transformations, unfortunately, it's a you either know it or you don't know it situation. You just have to know this chart. You have to know that adding to a function moves the graph up, subtracting from a function moves the graph down, adding directly to the x moves it to the left, so on and so forth. So I'm asking to describe the transformations present when you start at an f function and move to the g function. So this type of question, it's sort of a, what's missing, what's different. So if I started at 3 times x minus 4 to the 5th power minus 3 and went to g of x equals 3x to the 5 minus 4, you basically have to ask yourself, what changed? What's different? And now this is just a visual thing. It's not a calculation or a solving thing. So I hope we can see that we initially started with an x minus 4 to the 5th power, and we ended up with just a plain old x to the 5th power. We started with a minus 3 on the outside and ended with a minus 4 on the outside. So for the yellow, you ask yourself, how do you go from an x minus 4 to just a regular x? And I hope that you guys can just see it. You have to do a plus 4. For the blue, you have to ask yourself, how do I go from a minus 3 to a minus 4? And hopefully you guys can, it's just arithmetic. You have the minus 1. The critical thing here is to understand that the yellow, you're doing a plus 4 directly to the x, whereas the blue, the minus 1, you're doing it to the outside function. So for the yellow, plus 4 directly to the x, looking at the chart, plussing directly to the x is moving left. The blue, doing a minus 1 to the whole function, is going down. So there's your answer. Plus 4 directly to the x is left 4. Doing minus 1 to the whole function is down 1. Right. So left 4 came from the yellow changes, down 1 came from the blue changes.